Hi, today I'm going to be talking to you about Lesson 9-1, Parametric Equations. A lot of what we're going to be talking about is review from Honors Pre-Calculus. If you haven't seen Honors Pre-Calculus, that's fine. A lot of what we're going to be talking about is pretty simple. So here I go. A parametric equation, the whole idea is that instead of y depending on x, y is going to depend on t, and x is going to depend on t. Now the reason this is useful is that if they both depend on t, we can have things that don't look like functions, but will be functions. They're also useful because now we can describe a whole lot of motion very easily. So here we go. See, like this is a quadratic, this is a linear. Hopefully you all knew that. Maybe I should have paused. I don't know. Oh, okay. The idea is we're going to use some negative values and some positive values of t. You might not want to pick these. Sometimes it'll be easier. Sometimes it'll be harder to pick other values. And then I'm going to go right down the line, and I'm plugging these values of t into x. Negative 3 squared, 9. 9 minus 5, 4. Negative 2 squared, 4. 4 minus 5, negative 1. Negative 4. Negative 5. Negative 4. Ooh, it's bending around. Negative 1. One key thing is that the t values should go in order from least to greatest. Most negative to most positive. Whichever ones you pick. Let's use green. Y should have been even easier. Negative 3 halves. Oh, why'd I have to pick fractions? Negative 1. Negative 1 half. 0. Positive 1 half. 1. To graph a parametric equation, it's back to basics, guys. Happy day. I'm going to use pink to graph the points. Where's the point 4 comma negative 3 halves? X equals 4, y equals negative 3 halves. Negative 1 comma negative 1. Yeah, okay. I got phased. Negative 4 comma negative 1 half. Oh, someone here. Just draw it. I don't know why it does that. Negative 5 comma 0. Ooh. Negative 4 comma positive 1 half. Ooh. So interesting. Negative 1 comma 1. Right there. So what we see is this, well, if you said or thought parabola type motion, you're right. I missed that point. Oh well. A key thing about parametric equations is they have an orientation. Mark the orientation on the curve. That's these little arrows I'm adding in now. It shows the flow of the particle. The particle, as time goes on, does this kind of bend. So it's important to know that the particle is starting around here, ending around here. This should really be a dot. We know it's going to go on, I don't know. Arrow. You need to have arrows. You don't need to have a lot of arrows. You can have less arrows than that. Don't have arrows that conflict. I've seen a lot of people do that. That's wrong. It starts here. This is the first point I graphed. The negative 3. Time was negative 3. Time was negative 2. I started here. I just finished grading a BC test where many students didn't know to consider the fact that it could be negative 1 half. Time can be negative. It's okay. It's okay. So there we go. It's a sideways parabola, and now this is a function. We can do derivatives on this much easier. That's the key idea. Okie dokie. Change the following from rectangular form, standard form. We're just talking about standard. Y equals some function of x by eliminating the parameter. The way we're going to do that, oh, yellow's hard to see, huh? The way we're going to eliminate the parameter is by substituting. Or let's be rather solving and substituting. Now, before we go on, let's point out, why is t going to be greater than -1? Well, if t were equal to -1, this would be undefined and x would be undefined. If t were less than -1, that would be okay over here, but not over here. X would be undefined if there was a negative inside the square root. Just thought I'd point that out to you. It's important to note. So over here, the idea is we're going to solve for x, square both sides. One trick, you could cross multiply. You could just flip both sides, take the reciprocal of both sides. That works always. And so now I've solved that t equals 1 over x squared minus 1. Ooh, isn't that interesting? Okay, and now we plug that into y. So y will equal 1 over x squared minus 1. I'm just replacing both of the t's. Here. 1 over x squared minus 1. Sorry, there was a stapler emergency. Don't hurt yourself, guys. Let's simplify the bottom here. 1 over x squared minus 1. Yeah, that's a 2 somehow. 1 over x squared. I'm going to try that again. You can think of this as dividing a fraction. We're going to keep change flip. Or you can just think about multiplying the top and the bottom by x squared. Either way it works. I get 1 over x squared minus 1 parentheses times x squared. Okay? And you distribute it. 1 minus x squared. And here x is going to be greater than 0. We need x to be greater than 0 in this equation, or else that simply won't be the same as this. So why does x have to be bigger than 0? Because that's the only we're only going to get positive values of x using that parameter. Using any parameter that works. X cannot be less than 0. It cannot be equal to 0. Because this square root's always spitting out positive numbers when t is bigger than -1. So, what does this look like? You should say a parabola. When x is equal to 0, I'll have to do that. No. I want to use the positive values of x. Weird concavity. One more time. The positive values of x will be this. Okay, that was way too shaky. The positive values of x will look like that. And yes, again, I'm putting my orientation lines. Oh, I did those wrong. Good mistake. So, when t is -1, or close to -1, where will I be? When t is -1, or close, it would be 1 over 0, and -1 over 0. That's negative infinity. When x is going toward infinity, y is going toward negative infinity. So that's way down here. Check t equals 0. T equals 0. Y would be 0. X would be 1. That's this point. Try t equals 1. 1 over root 2, who knows, 1 over a half. That's something up here. So the idea is that my orientation is going this way. And that's how you can check. So forget checking like -1 exactly. You can just check any number that's easy to check. Check 0, check 1. Make sure you're getting these orientation lines correct. I will be harsh on your test. They will be harsh on your AP test. Eliminate the parameter. Ooh, in this case, the parameter is theta. Now, this is a classic problem because some people are going to see this as polar. And it is kind of polar. So we're going to talk about this a lot more in 9-2. How can you eliminate this parameter? The way to eliminate parameters with cosine and sine is always to use the Pythagorean identity cosine squared theta plus sine squared theta equals 1. Yay. Now what's cosine squared theta? Oh, cosine is x, so that's x squared. What's sine theta? Sine, just to make it really clear, is y over 3. So that's y squared over 9 equals 1. Now, what kind of a graph is that? What kind of a graph is that? Does anybody know? How quickly we forget, right? This is the equation for an ellipse. We see the equal 1, you see x squared, you see sine squared, you see x squared, you see y squared, you should think ellipse. Equal 1, you should think ellipse. Especially if their coefficients are different. 9, dirty. Alright, bonus points if you can tell me whether this is an ellipse that's tall or an ellipse that's wide. What does that 9 do? Okay, that 9 stretches it out. That 9 stretches it out vertically. Whichever coefficient is bigger on the bottom, so whichever coefficient 1/9 versus 1 is smaller, it's more stretched out along that way. So points I know. When x is 0, let's just stop doing this work in our head. X equals 0. We would get y squared over 9 equals 1. Y squared equals 9. Y equals plus or minus 3. And then we check out when y is 0. X squared equals 1. X equals plus or minus 1. So we have those 4 points on our ellipse. Again, you need to know it's an ellipse. We'll try to make that clear in 9-2, how you can tell. Alright, now we need to check our parameter. When theta is 0, what point am I getting? Cosine of 0 is 1. Sine of 0, 0. So it starts here. Now let's try theta of pi over 2. Theta pi over 2. Cosine pi over 2 is 0. Sine of pi over 2 is 1, so 3. So we're going this way around the circle. Okay. That's all there is to eliminating parameters. Now, in not every case, you're going to have to eliminate parameter. A lot of times they're going to ask you to find the slope. Find slope. If they ask you to find slope, slope will always mean dy over dx for parametric equations. A lot of people think it means x prime, y prime. Slope. This is slope, guys. You need to know that. And sometimes they'll ask you about the second derivative. Second derivative test, right? We know why that's helpful. So it's possible to do all this hard way, but it's easy if you have this equation and this equation. Now, some of you might not know where these equations come from. You don't really need to know them. You just need to make sure you memorize this. It's heavily important, highly important that you memorize all this. You must memorize it. Where does it come from? Well, the chain rule. dy dt would equal dy dx times dx dt. That's the chain rule. You might not have known that ever, but that's what the chain rule is telling you. Is that if I want to differentiate y with respect to t, I first take the derivative with respect to x, the outside, and then I find the derivative of the inside, right? Because y of x of t. That's how we're kind of picturing it, okay? Again, you don't need to know all this. You need to memorize it. You don't need to know the pink. You need to memorize this box. I can't tell you how many points were lost on the Unit 9 test last year because people did not memorize this. Here's how you apply it. It'll be sometimes as straightforward as this. Find dy dx, find the second derivative. D squared y over dx squared. So what I need to do is I need to find dx dt. Just differentiating, that's all, with respect to t. Negative sign, good. And dy dt, just differentiating this guy with respect to t. 3 cosine t, 3 cost. So dy dx, and it tells you, it's in the name, it tells you do y over x, 3 cosine t divided by negative sine t. And sometimes it's helpful if you simplify this a bit. Negative 3 cosine over sine, cotan. And here's why it's going to be helpful that we simplify that. Because sometimes they'll ask you for d squared y over dx squared. I'm going to write this equation down. So many points were lost because they thought they could just differentiate this. You can no longer just differentiate this when it's parameterized. When there's a t and you're differentiating with respect to x, you must use this formula. The tth derivative of dy dx, and then we're going to divide by dx dt. So, the top part, d by dt of dy dx, the derivative with respect to t of negative 3 cotan t. What's the derivative of cotan? Now, this is hard. I don't know why I did that. It's so annoying. This is hard because a lot of people don't think in terms of the cofunctions, especially cotan and cosecant don't come up that much. Think about what's the derivative of tangent. It's secant squared. The derivative of cotan is negative cosecant squared. So this derivative would be negative cosecant squared t. Okay? In case that's not clear, I'm talking about negative 3 times negative cosecant squared. That's why it worked out to be positive. Okay? Good? So, the top part's done. So that's why it was helpful to simplify. You can do the quotient rule if you want, I'll stick to the trig rules that I asked you to memorize months ago. It's months for AB or BC students. If you're an AB student watching this video, it's okay. There's still time to memorize it, even if you're a BC student. It's just that you should have been memorizing it all year. And I divide by sign. I divide by sign. Guess what? Guess what, everyone? What's 1 over sine? What's 1 over sine? It's just another cosecant. Now, on the test, I wouldn't expect anyone to do that, really. I would expect you to box your answer if this was free response. But if you saw this as an answer choice and you didn't see this, you need to know how to get here, and that's why. Okay, right? One of the strategies is always to write everything in terms of sine and cosine, and then try to simplify. Okay, like this is 3 over sine squared times negative sine squared sine. Okay. That's what I'm talking about. Alright, now I already previewed this. Find the slope and the concavity. Even in parametric form, the slope is always dy dx, and the concavity is always d squared y, the second derivative, dx squared. I don't want to say second derivative anymore, because you can take derivatives of this and derivatives of this of y by itself. You've sort of been doing that all year. dy dx, what's the formula? Well, it's dx dt. When you calculate that, what's the derivative of root t? It's 1 over 2 root t. What's the derivative of y? It's t over 2. Power rule. So now dy dx would be the y on top, the t over 2 on top, and I'm going to divide that sucker by 1 over 2 root t. Keep change flip. Simplify it out. T to the 3/2. Just because I know I'm going to be needing to use the power rule. So that's dy dx in terms of t. So that's the slope. That's the slope. Okay. Let's do... So they want at this point. So I'm asking about dy dx at 2, 3. So what goes in for t? Very hard. Very hard. A lot of people have an instinct to plug in 2 or 3. Both of those are wrong. You have to find out which value of t gets you to this point, 2, 3. How can I do that? Set whichever one's simpler equal to whichever one. So you could solve the equation 3 equals y. It's not that bad. Or you can solve the equation 2 equals x. 2 equals root t. T equals 4. Now I said you could do it with y. Let me show off my algebra skills. 3 equals 1/4 t squared minus 1. 4 equals t squared over 4. T squared equals 16. Now the problem with this, you get 2 possible answers, but they say t is greater than or equal to 0. So t equals 4 or negative 4. And obviously we rule out the negative 4. Where am I getting this from? I feel like some of you are watching this and like, what happened? How do you get this equation? If 3 equals y, I take this equation and I replace y with 3. If 2 equals x, I take this equation and I replace x with 2. So this derivative equals dy dx evaluated when t equals 4. 4 to the 3/2 power. And again, maybe you don't want to write it like that. Do the square root first, guys. I know you can do it. The square root of 4 is 2. 2 cubed, 8. So that's the slope. One more time, that's the slope. You should have programmed yourself to know dy dx is slope. The key thing is not forgetting that programming, not treating dx dt as slope or dy dt as slope. Okay, now we have to do concavity. So concavity. A lot of my colors look similar now. I don't know. D squared y over dx squared. Remember, we're going to do it this way from now. Well, at least whenever it's a parametric. The tth derivative of dy dx over dx dt. What's the tth derivative of this? It's 3 over 2 t to the 1/2. It's just the power rule, everyone. That's why you want to have it simplified. You should always try to simplify dy dx. Power rule. Over dx dt, which is still 1 over 2 root t. Keep, change, flip. I'm just trying to write it nice, guys. This all simplifies out so nicely to 3t. Boom! So? Wow. Why does that pop up? It's so dumb. Whatever. So, the concavity at my point, 2, 3, is the concavity when t equals 4, which is 3 times 4. Drum roll, please. 12. Which means it's concave positive. Concave positive is concave up. Good. Hopefully you got there before me. Alright, let's see another quick application of parametrics. You should love parametrics. It's going to feel like coming home after all that horrible time in series. Trust me, that's how my BC, the students in the class, are going to feel. Okay. Write an equation of the tangent line to the curve defined by x equals this, y equals that, at the point when t equals 1. What do I need for a tangent line? I always need a point and a slope. And here's what I mean by coming home, guys. What's a point? X comma y. So I need an x coordinate and a y coordinate. So let's find x of 1. 1 minus 1. I'm using this equation, guys. 0. Y of 1. 1 over 1 plus 1. Or 2. So my point is going to be 0, 2. That's one part. Slope. Dy dx. You must think I'm crazy because of how much I'm emphasizing that you need to do dy dt over dx dt. Well, I might be crazy, but I also saw everyone mess this up last year. What's the derivative of y with respect to t? I'll write it down here. dy is the hard one in this case. Dy dt. What's the power here? I've told you also before to memorize this. Dy dt, t to the negative 1. Negative t to the negative 2. Or in a positive exponent form, negative 1 over t squared. That's what dy dt is. Dx dt 1. Isn't that lovely? So we have negative 1 over t squared divided by 1. So the slope dy dx is negative 1 over t squared. So the slope when t equals 1 is negative 1. I'll write it out. Over 1 squared, which is negative 1. I have a point, I have a slope. If you are using anything besides point-slope equation, I don't know, slap yourself in the face. That's so silly. Like, I can't tell you how it bothers me when people are doing this on the test where they have to set up a little mini system, solve for b. It's so silly. That's the way my 7th grader does it. It bothers me that he doesn't know about this magnificent, beautiful thing because you're done. You're done. When you guys show me anything else in the test, I have to take my answer key and solve it. And I know you're like, wow, Mr. Leven, you can't solve it. I'm not saying I can't solve it. I'm saying this is not any more clear than that. To the well-trained eye, this tells you everything you need to know. This doesn't tell you, this obfuscates some things. Anyway, you guys are right now like, what's obfuscate? I don't know. Tell me if this alerts your spell checker. Obfuscate. Look it up. Word of the day. There you go. Arc length revisited. If you forgot arc length, it's at the end of section 5-1. I'm pretty sure you all forgot it, depending on how you're watching these videos, but I didn't because I recorded 5-1 like last week. And that's the only reason I didn't forget that it's in this course. Before now. If a curve is smooth and does not intersect itself, you usually won't be responsible for checking those criterion. The AP test will just say, weirdly, hey, dum-dum, this is a smooth curve that doesn't intersect yourself. And you'll say like, oh, I could use the arc length formula. How wonderful for me. In case you forgot, why does arc length work? Why does arc length work like this? I have myself a beautiful equation, and I want to find this little chunk. The idea is that every single function can be chunked out into lines. That's like the key idea of calculus is linearization. And now, if I zoom in, okay, hold on tight, guys. It's about to blow your mind. Bam! So I zoom in. Guess what? That little chunk, and this will be really familiar if you've studied physics at all, can be broken into components. So the hypotenuse change is related to the dy dt change, the dy dt change, and the dx dt change. And even if you haven't considered physics, I kind of drew it in a very helpful way. So this is dy dt squared plus dx dt. I should have done it the other way, huh? Dx dt squared over dy dt squared square root using the Pythagorean theorem. And I want to add up all these little black lines to get the whole picture. That's how it works. That's helpful to memorize this formula, trust me. I'm adding up a bunch of little tiny hypotenusae. I'm pretty sure it's hypotenuses. I'm pretty sure that's the right way to say that. Anyway. Arc length. So I'm going to need dx dt. Oh, look, it's using example 7. Dx dt was 1. Yep. I had notes. I'm not that smart. Dy dt was, I mean, I called it. I was right about that, but I checked on my notes. That's why I didn't see me turning the page. Negative 1 over t squared. Beautiful. So the arc length, and I don't know, one thing that you guys drive me crazy with is your refusal to label. Arc length from t equals 1 to t equals 3. Where do I get that? Right there. It tells me what to use. Square root 1 squared plus negative 1 over t squared squared dt. You should simplify before you plug it in your calculator because, I don't know, the calculator might cry looking at that. 1 over t to the 4th. Although, I don't know, some of you might not be able to simplify that correctly. Just saying. I said it already, plug in your calculator. Arc length is always on the calculator section because you guys can't usually integrate things that look like this. If you try to do it by hand, you're probably doing it wrong. You have to know a special technique to integrate square roots that look like this. 2.147. Try it out on your calculator. Make sure you can get that. That's all I have for 9-1. If you have any questions, please come talk to me about this. It's not that bad, but again, you could spend a month in pre-calculus on this. And that's the non-calculus portion of that. Okay? It's not that bad, but I got your back if it's confusing. Alright, so make sure you do 9-1. You will not pass the test if all you're doing is watching these videos. I guarantee it. I'm not that good of an explicator. I can't answer all the many questions you probably have. A lot of your homework's going to ask you to do some fun stuff. So do the 9-1. Do the training. We're almost there at the finish line now. If you have been doing all the lessons up to this point, thank you for your hard work. I really do appreciate it. And you guys have a nice day or a nice night, depending on when you're watching this. All right. Talk to you later. Bye-bye.